Hello students. So we were discussing surface area and volume. So in the very beginning we had seen what are the various formulas of a cube, cuboid, cone and various other three-dimensional bodies, right? Similarly, we had seen the very first type of questions where combinational solids were involved. If you remember, what exactly is combinational solid? Where one solid structure is combined with another solid structure, and based on that, like the volume or the surface area was asked, right? So today we'll be discussing the next type, that is type 2. So in type 2 questions, let's see what kind of questions we see. That is conversion of a solid from one shape to another. So over here a solid is converted into another solid. Okay, we'll take very few basic examples, and in that only we'll try to understand what they are trying to tell us. But in overall, a general idea of this particular type is where you take a particular solid, what you do, you convert it into another structure. So over here, like for example, I took a cube, I melted it and I recasted it into a sphere. Now the cube is there and there's a sphere. Now both look different, right? Which means what? Their surfaces are different, which means their surface area will be different. But when I am melting this cube and I am recasting it into a solid sphere, the amount of metal which is there, that is fixed, that is constant. So basically, whenever you convert a particular solid from one shape to another shape, its surface area changes, but its volume is always constant. So this is a very key important point which you need to understand over here. Let's see an example. So the very first example I have taken over here is, if a solid metallic sphere is melted and recasted into more than one spherical balls, which means what? You have one big metallic sphere, okay? You melt it and you make small metallic spheres. So in this scenario, a big sphere is converted into a number of smaller spheres. So in this scenario, what you have to understand is the volume of the metallic sphere, that is the volume of the entire big sphere, is equal to the sum of volumes of all spherical balls. Like let's say for example, I have this big spherical, you can say sphere, okay? I melted it. Then I made small 10 balls, which means the volume of this particular sphere should be equal to the volume of all the 10 spheres combined together. That's what they are trying to say. Or in simple terms, volume is always constant. Just remember that, okay? Then I've taken one more example. Over here, students have a little bit of difficulty with the language of the question. It is very rare, but still I feel like you should understand it. If it is asked in board exam, it will be very helpful. So the second example is, if the earth taken out by digging a well and spreading it uniformly around the well to form an embankment in the shape of a cylindrical shell from its original shape of right circular cylinder. So see, the very first thing you have to understand over here is what exactly is happening in this question, right? So over here a well is being dug. Now what exactly you do? You dig the soil, right? So as soon as you start digging, you dig deeper, the more deeper the well is, the more amount of soil or earth will come out. That is like spreaded around the well. That's an embankment, okay? So the important point over here from mathematical point of view, you need to remember that volume of the embankment is equal to volume of the earth taken out by digging a well. The amount of earth which has been dug out, that is only spreaded evenly. In other words, the volume will be constant. So I hope you understood the second type, where only one thing you have to keep in mind, that whether you convert a solid into a different solid or into the same solid of number of particular small entities, in both the scenario the volume remains constant. I hope you understand this. Hello students, so we were discussing type 2 questions of surface area and volume. Now we'll see two important formulas which will help you solve type 2 questions in a much easier way, and it will also help you analyze the question, which will again help you, like, in understanding the question to its core, and which will help you make like less mistakes. So the very first formula which we will be saying is volume of the solid to be converted is equal to the total volume of the solid into which the given solid is to be converted. Like for example, let's say I took a cube, okay, a metallic cube. I melted it and I recasted it and made a sphere out of it. So over here the volume of the cube will be equal to volume of the sphere. So in this scenario volume will be same. Or let me give you another example, like let's say I took a big sphere, I melted it and I made 10 smaller spheres. So over here the volume of the big sphere will be equal to the sum of the volume of all the 10 spheres. Okay, so in this scenario volume will be constant. Similarly, let's see the second formula. Number of solids of a given shape in which a given solid is to be converted. So over here you need to find how many particular smaller objects have been formed from a bigger object. Okay, so for that what you do, you always take volume of the solid to be converted, or in other words volume of the bigger object upon volume of one converted solid. Okay, volume of a single small solid. If you do that, that is divide the volume of the bigger object by volume of the smaller object, but only one. So you will get the number of objects in which it is converted. So these are the two important formulas which you need to know for solving type 2 questions. We'll be seeing some examples based on that.